Welcome to a glance at the Java Performance Toolbox. Thank you for coming in such a big number today. Hope you'll enjoy the talk. So this is me, by the way. Probably some of you have seen this video. Some of the tools in the video, I think, are going to be in this presentation too. However, if you want to know what changed with the JDK tools since JDK 17, give it a try and watch this video. And I'm looking forward to receive your questions, of course, on today's presentation, but also more on the JDK tools. Now, apart from that, and the fact that I don't wear that hat today, because I forgot it at home, I'm Anna, currently working as a developer advocate in the Java platform group team. And I'm passionate about solving problems that involve Java and working with it in containers. Today's talk is going to be Java, and of course, it's going to be a little bit of Java in containers. But let's start with the part that was in the title, and what does application performance mean? So if I'm going to ask you, probably some of you already have your own definitions based on your experience within your projects and based on what you know that the goals of your applications are. But moreover, the performance can be seen from two angles. So the end users of the applications that you're working on perceive performance as the ability to use your application in an optimal amount of time. So they manage to do what they want to do with their application in the time they want it, and they just don't spend a lot of time doing that. Now, your business likes that too, and they perceive performance with, okay, how many users love what we're doing, what our business does and stays with us, but also perceive that with how many resources is that type of user experience consuming. So they see it from the computational resources point of view. And because there's these views, and sometimes you need to explain to people, how do I know that my application is performant? How do you tell me that this application is performant? You're probably gathering metrics, right? And these are just a few metrics that maybe you gather to demonstrate that your application is performant, or maybe you can do better. So like CPU usage, memory, but also sometimes you get the user's feedback. And you get the user's feedback, and you can track that and how satisfied they are sometimes with how much time they spent doing a certain action on your website, or if they abandoned doing something on your website. And, well, because we want to be more performant nowadays, we like to have our workloads deployed faster for applications to benefit of the computational resources available in the cloud. And now that we move to the cloud, everything's possible, and we can do everything there and solve all our issues, and our applications are performant, right? So that's the case for each of us, right? But moving to the cloud brought more questions. More questions about, okay, so now I move my application in the container. How can I work with it in a container? How can I make sure that what I'm deploying in that container works as in my local? How can I proxy the output of that? How can I go and make sure that I'm actually installing what I need, only what I need for my application, and not adding something that I don't need? How do I know that my application is performant? How do I capture what is my application is doing and correlate that with how performant is my infrastructure? So we're going to try to figure out the answers to these questions in the presentation today. Let's start with the first question. So if I'm to ask you which tools help you create your container images with only what is needed at runtime, probably some of you will tell me, well, it depends. It depends on what I like to use, because maybe I like to use the tools that I've been accustomed for a while, like Jib or BuildKit or others. Or maybe I like to use the plain old Docker file. There are a lot of options nowadays. Now, this is just a list of what I used, and actually this list grew in the past year. But I don't want to have a lot of bullet points in my slides, so I just listed these. There are a lot of options to build an OCI-compliant image. But I think we all started with the good old Docker file. So can you please raise your hand if you ever touched a Docker file? You ever wrote? Good, that's great, I love that. So Probably you've seen this kind of syntax, right? You're starting with a from, and you're like, okay, it has to be the smallest from image as possible because we don't want to have a big image. And we're doing that not just to preserve our overall image, a small one, but we also want to have the ability to create images with common layers. So we usually kind of stick to the same from in our images for that. And later on, we just copy what our application needs. Of course, we add some permissions to that because we don't want for our containers to run with root, and what would be bad. But what I'm showing you here is a Docker file that runs with GRE10. And I think we heard a lot of presentations about JDK 21. So what happened with the GRE starting with Java 21, with JDK 21? Can somebody tell me? I hear somebody saying there's no GRE, yeah. So they're starting with JDK 11, there's no GRE delivered in there. So what we're doing, how we're building our froms, how we're running our applications. Well, there's a JDK tool. There are actually more JDK tools that can help you shape efficient Java runtimes for your container images. So you don't have to necessarily go and do magic with other tools. You can still keep your Docker file. And the first tool that I want to talk to you about is JLink. Now, you can use JLink tool to assemble and optimize a set of modules and their dependencies into a custom runtime image. So what this means is that your application is using a set of modules, and you can just pick only those, because only those are needed at runtime, and build your own GRE. So how JLink packaging works? Well, in the legacy JDK image, you used to get this. You used to get a bin, a GRE, and a lib. But while starting with JDK 9, when JLink became available, you can make your own GRE with only what is needed. So what does that mean? It means that the previous Docker file would contain, from my point of view, a runtime stage build, where I would like to build my GRE with only what is needed, and then it will contain an application stage build, where I would like to use the GRE, because it's minimal, just copy the artifacts of my application and run my application. So now the runtime stage build becomes something like this. So you can see JLink here. And, well, you're using a from, that's a JDK image, because you need the JDK for JLink. You need to add some modules. And some of you will be like, okay, so how do I know which modules to add? Because when you're working within your favorite framework, you're not adding modules, you're adding dependencies to build your application. So you can identify those modules that your application is using thanks to another tool called gdeps. You run that once, it gives you a list of modules, and you just copy-paste them in the --odd modules. Easy as that. Now, I just don't want to have anything else in my GRE, so I keep the no man pages and no header files. And I compress it to zip, so I want to have it as small as possible. And, of course, I need to put somewhere that GRE to copy in the next stage. Next, the application stage build, of course, is copying from the previous build. And then I'm just going to continue what I did before. Copy my application, run my application, and so on. Easy as that. Good. So, those being said, let's see how that looks like in my demos, because we're going to work with something. So this is the Spring Boot to-do app. Probably you've seen many times a to-do app, how it looks like. Runs on JDK 21, because I wanted to work with the latest JDK. And, of course, has the Docker file that I spoke to you about earlier, with the JLink, with the modules that I need to run my application, and of course, with just a base image with my operating system to run that application. And I spoke about containers. I'm going to simulate a bit of the containerized environment within Docker Compose. And I'm going to build my application every time that I update something within it. So I can, just simulate the working of a Spring Boot app, that is exporting its metrics to Prometheus, and of course, that Prometheus is becoming a data source for Grafana. All in this in a Docker Compose, that you can try on your local. So let's start our application. hopefully with good internet. So docker compose up minus build means that is going to build my application on the spot. So I don't want to use something that's available on the internet. I just want to build this on the spot. And while this is being built and ran, I need to put a little bit of, actually, before doing this, I want to see how much memory this application is consuming. And if some of you will say, like, go to Prometheus and go and see that. True. But I'm still on my local, and I have a little helper script that can print for me the PSS memory that I am using. That is from a colleague of mine, by the way, so it's not my idea. It's borrowed. So let's track a little bit on how the memory usage is. To run this in a container, of course, I need to cat this, and, well, because it's running in Docker, docker exec -i. I need to go a bit to Docker Compose and get the name of the container, which is Spring Boot to-do service, and of course, bash. So what this does is executing that script inside my container directly. And you can do the same thing with kubectl exec, so it's the same thing. So I can see that while my consumption of memory is pretty low. Let's add a little load to our application. Make some users, make some noise in it, put some pressure, and see how that is going on. So my expectation is for memory to grow, but not that much, because I'm not, using at maximum my app. And I designed it very, very well. So I'm very certain it's going to go great. However, what I'm seeing is that the memory usage just keeps on growing. And yeah, I'm going to disclose something. My app has an issue. And we're going to troubleshoot that together. So the memory keeps growing up. And as a developer, I'm thinking like, okay, I need to figure out something. And you know what? I'm going to go and see, maybe I can fine-tune the JVM flags, because maybe that's when you Google or say maybe there are some flags that you didn't set for your JVM, and you can improve something about your memory. So the first thing that you're going to do, you're going to probably land up on a page that contains the JVM ergonomics in the documentation. It's going to give you some information about setting up the XMX and SMS parameters to specify the space reserved for your memory, And then you're going to see that, well, maybe I can squeeze it even more and say that, well, what's the percentage of the free space for my memory? So for example, with the max free heap ratio and min free heap ratio, what you specify, like if the percentage of free space in a generation falls below those 10%, then the generation expects to maintain the 10% of free space. And the maximum free space means that if that is exceeded, like exceeds 70%, the generation contracts, so only 70% of the space is free. Okay, so I would do that, okay, for my application. And if I'm looking here, I already set that up. So it's not that the problem. Okay, now come back next. We have to set more flags. Because maybe the problem is not the amount of resources allocated to and by the JVM. So maybe we can send some diagnostics to the JVM. Now, to help us with sending diagnostics, we need to use a tool called jcmd. Now, to add jcmd to what we already have, because our application works only with modules that makes it needed for running at that moment, and we need to add our tool to our GRE, well, I'm just going to add the module jdk.jcmd, and that's it. So just add for that for JCMD usage. Now, a small warning, if you overuse the diagnostic commands, is going to produce some overhead for you. So what I need to do now, I need to add a flag, the native memory tracking, to track how my native memory is being used. And hopefully I'm going to get some information about that, and my problem will be solved. Identify where's my issue. And this is the command that you can use, by the way, from if you're running it in Kubernetes and you just want to inject this one time from the environment. It's way easier than hard coding things in Docker files, for example. Now, how to use the JCMD? Well, to look at the memory. First of all, you need a baseline. You take a snapshot in time, how was my native memory usage at that point in time? Then you need to compare that to something. So you do the diff. the diff can be used to observe the change, where exactly memory is being used. And if there are indicators of like big growth in a small amount of time of memory, there could be your native memory leak issue. So, without further ado, let's go to see how we can use jcmd. First, let me stop this, because I need to reload my container, which already doesn't respond anymore, and add the flag, -xx native memory tracking, and I'm going to set it to summary. Okay, now that we did this, let's restart the Docker Compose. Bully is going to be picking up easy. I don't like you. Come on, stop. Yeah. Sometimes scripts don't listen to me. I don't know what happened. Okay, good. I also have a way to kill it with pit off, but anyway, let's not get too brutal with it. So, okay, it starts doing work. Now it's the time. Okay, so I can take a snapshot of that. I need a baseline. And in order to track that, I created a script that you can use to exec in my container and take that snapshot at that time. I make the baseline. So, chtrack.ch, it's going to take the baseline. It's going to wait 10 seconds after I took the baseline, so to give me the diff in time, what happened. And next, yes, I want to run a difference. It's going to output the summary diff. And what I did, I outputted that into recordings area so that I can see what's going on there. But didn't write something. Hey, did I open it too quickly? No, it's there. I know that is there. I can show you. Docker file. jdk.jcmd here is there. So I'm going to try it again. Maybe I was too fast, or maybe didn't wrote something to it, because it should echo something in the summary diff. Why is this not working? For me. All the time it outputs something with my diff. Okay, so I have a backup stuff that I can show you to you. Good thing that I've made some backups. So, with the summary diff, you usually get something like this with native memory tracking on. You get a usage of your Java heaps allocation, and you're searching for increases of memory allocation for different areas. So, for example, allocation for class files. So, if there's like a big increase in memory here, that would mean a problem for you. Or many threads that are, needed instantly in those 10 seconds. Or maybe your code or the GC needs more memory. But in this case, there's no issue with this one. So maybe the problem was not exactly my allocation of the native memory, and maybe the problem is in my code. So how do we do that? How do we identify there's a problem within the code? Within the code, well, you can sometimes look in jconsole and look at the heap memory usage there as well. And if you can see the line that's going down, this means that wasn't out of memory and my application died. So that's where it's going down at some point. It's going to hit out of memory. And it's going to be a little inexplicable in my case. So I'm thinking like maybe I should get some statistics about my running Java processes. Okay, which processes within my JVM are consuming most of my memory? And for that, I have two tools to help me. The first one is called jstat. That one can give me information about the performance statistics on my instrument in JVM, And in this case, what I'm saying to my running JVM, hey, give me some statistics about how garbage collection behaves by taking 50 samples of that every 500 milliseconds. And if that's not enough, but for statistics point of view, I would also like to see how is my memory-related statistics in terms of like objects. So jmap is a command utility that can help me with that. And in this case, that command prints a histogram of the Java heap object for the Java process that I'm looking into. And that's the command for Kubernetes if you need to run it, and not just locally. Because locally things are easy. Okay, so let's go back here, and let's run those commands and see what's going to happen. Didn't this? Okay, now it wrote the summary diff. So it takes a while for my computer to write something. Or maybe my application is slowing down my computer. Okay. So first, let's see how the statistics are going on. Again, helper script for the situation. Let's clear this and query my application. So I want to take a GCUDL and see like what's going on there, like every 500 milliseconds. And the minus H10 means like print the header in that file every 10 lines. Because what's going to generate is going to be a file that's you're going to scroll a lot in. And maybe you want to know what was the header of that file at some point. Okay? And of course, at some point, it should ask me if I want to print the heap summaries. So yes, I'm going to print the heap summaries and the histogram for my process. Okay, so hopefully this is, yes, has some information in it. And let's look about it. So let's see how garbage collection behaved. What I'm looking into is the promotion of the objects from Eden space to old space, and how much time that took. And I can see that the promotion of object happened on the first line, and it took almost 10 milliseconds. Which is quite a lot, but of course the memory of my application keeps increasing, not much is being freed, so probably makes sense. Then I'm seeing that whenever I'm looking at the garbage collection, that the garbage collector is working and the promotion happens between Eden space and old space, that time takes again 10 milliseconds. So it seems that the time that the garbage collection is spending on collecting objects is quite significant, but the memory is not freed enough in time to fix my issue. Okay, so maybe I could fine-tune the garbage collector. That would be an option. But maybe I need to wait a little bit about that. Let's look at the histogram of objects. So the histogram of objects, you get the number of instances and the bytes allocated for each class module. So if you're wondering what B, C means, they're actually meaning the get class name for byte in char. So that's what they mean. And filler array means the classes that are marked as the area in the heap that is marked as with dead objects for the garbage collection. So there are some dead objects there, and they've been marked with the filler arrays. This is a change from JDK 19, by the way. Okay, I'm looking here. I can see that I'm using a lot of strings, a lot of hash maps, entries, but I'm not seeing much that could give me value for knowing where exactly my problem occurred. So now I'm going back and thinking, maybe I can get in-depth information from my application again by looking at events. So sometimes we need to know like which events from the JVM triggered a certain behavior, and we would like to capture those about our application and correlate them, if possible, with whatever we're having in the monitoring tools. So first of all, because now we know we have a problem, we can do profiling. And we're going to use JDK Flight Recorder for that. By the way, for profiling, you typically need just a few events enabled. So just you don't need to catch all the events that happen in your JVM. And well, GFR was built to emit this data at very low overhead. So that's something for you to remember. And this data is eminently useful for you to get detailed information about what things are making your application not performant. So all the time think about GFR, using it for profiling. So I'm going to use, and I'm going to add my tool to the container image with the, sorry, I made here a mistake, it's jdk.gfr module. I'm going to then enable that one for my app. So I'm going to start a recording. And I can start a recording with the -xi start flight recording, and then execute a diagnostic command to capture a recording about my application. There is another way, which is the programmatic way to capture a recording, but I would like to show you this one as it's controlled by the environment. The programmatic way would tie you too much to the application from my point of view. So let's do some profiling. First of all, I need to update my application to use GFR. So I need to start my flight recording. I want to output the recording in the recording.gfr. I'm going to use a custom profile that's shared in the repo, by the way, so it's nothing hidden. Keep a max stage for my recording for 5 minutes, and of course, if my JVM is dying, just dump a recording while that is exiting, just in case. So, again, trying to stop this, hopefully. And then my container to reload what's going to happen with it. And clear this. So let's restart the app up with the new flags. And of course, I'm going to perform a recording on it and some other things. Oh, come on, die. When you want things to die, they don't. But the application is dying at some point. That's the very interesting part of it. OK, so everything started. Let's load again on it. And let's do a recording. So we need to execute the jcmd to it. To do that, OK, I'm going to do a jcmd. I'm going to dump my recording. But besides that, I want to see what's going on within the allocation. I mean, which methods are being mostly used. How is memory allocated, if there are memory leaks or anything else. And starting with JDK21, there is a new command for GFR called GFR view that allows you to do that. So I can get more information about what's going on within the JVM directly with GFR view. Let's do that for now. So record.ch and dump the information there. OK? Hoping for the files to be created soon. Good. Let's hope that something... Oh, come on. Not again. My computer is so slow when the application is consuming a lot of memory, unfortunately. Let's see. OK, so the hot methods was written. Hot methods means the most used methods within my application while users interact with it. So it says that I'm using remove first occurrence with concurrent link deck, which I can search within my application. I'm for sure not using it, but it seems that I'm using it intensively. Maybe something in the framework uses it. Then HTTP 11 processor, I don't know what that is, but this one, the first one, seems to be the one that is causing a lot of trouble and is using a lot of my memory. Then I'm going down and not seeing much about my application. I'm trying to look also for some code that I created. Maybe there's the problem, but I don't see it. So let's dig a little deeper. Let's look into the memory leaks part, but of course I didn't write it. Great. Let me stop this. My computer's getting slow. So we got our recording. What do we do with it? The way that we can look at the recording is in the JMC, in JDK Mission Control. So we can analyze the recording in the JDK Mission Control and see what happened with our application. Now, for the memory part, and because I need to find out what's the issue with my app, the stack trace part is going to be the most useful for me. So looking at the recording and the memory, and the fact that I'm using a lot of memory, and I have enabled only the garbage collection and the use heap map, and I can see that I kind of reach at some point the maximum of 768 megabytes that I allocated to my container. And drilling down into the stack traces that I see here, I kind of finally find some piece of code that is mine, that I created. So I kind of have a starting point of what happened, where the issue is. So my problem, and I cannot enhance this view, unfortunately, started in the to-do controller whenever I add a to-do item. And then there's some lambdas here, and there's some arrays. And I can also navigate sometimes in the stack if I need to. So I can choose the next frame group, for example. and still navigate to that. Okay, so the hot methods told me that I was using a lot of deck of the collection there. I was trying to remove first all the time. And this one tells me the problem is in add to do. So something with the collection is wrong within what I'm doing in maybe add to do item in the first part when I'm posting information. Let's go back to the code and look now. So let's go to the source, to do, and inspect what happened to the to do controller. This is the add to do new to do item method. What I'm doing, I'm setting a new ID, I'm saving to repository, that's good. And I'm looking here into this tags. Tags is a hash map that I'm initializing, so whenever I'm saving an object to my database, I'm creating some tags for it. And the way I'm doing the tags, of course, I'm using the item that I'm saving as a key, and then I'm doing something with the content of it just for the sake of it. And then I return my response. Okay, so this is the collection that I'm using. But there's nothing wrong with it, right? However, if I'm looking down in my code, I'm also updating the item at some point in time. But I'm just, updating the item. I don't care about the what I did with the tags anymore. And if I'm going down in the remove part, I'm deleting the item, but then I'm removing the tags as well. So what happened? What happened part is, when I'm saving my tags, every time I'm doing put with the item I put as a key, well, when I'm putting in the collection, I'm using both the key and the value to find and allocate an entry, a bucket for my items to be called there. But I'm doing that based on the hash code that item has. Now, when I'm changing item, I'm changing, of course, its hash code, but that cannot be reflected into the initial save that I did. So what it happens is that in my collection, I end up putting more items while the initial one can never be found again as the hash code has changed. And that's why remove, even if I'm doing remove cannot find it all the time. And that's why my problem is. That's why the memory is increasing all the time. So now that I kind of find out the problem and why it's growing and why application is dying, I can fix that issue. So this is kind of a little known problem with allocating objects in the hash map and how to put the keys and the values within it. But I knew that I had a problem with my application right from the beginning. And you can say, like, hey, you knew from the beginning that there's an issue. And how can I identify that there's an issue for my application when I know that everything's going great? True. How can you do that? Well, you do have tools that monitor your application, hopefully. And most of the times, these tools pull metrics, the ones that we talked in the beginning, from your application. And you gather the metrics, you visualize them, and they can alert you. Now, GFR has a very beautiful API for events. So you can use GFR streaming to stream events related to your JVM and get those events in tools that have registries like Prometheus, for example, like Micrometer does for your endpoints. You can gather the same way for the GFR events. How do you do that? Well, in the slide, you have the example, and that's actually from the actual code. In this case, you open the repository of your recording, you look at the events, you choose the events that you think are relevant for recording, for knowing what's going on with your JVM. And in this case, I want to know what happened with the heap, And I want to know how many bytes were allocated by the objects in the heap. And it would be good to have a trace of that over time, right? And I'm making a gauge, registering that to my material registry, and I can correlate that with the other events relevant within my application, like how many requests were done to my application. So the JVM versus the overall by endpoint requests that we knew. Next, so GFR streaming is useful for finding those averages, min, maxes about your JVM events. And also those events can be directly connected to an MB server connection, for example, like in this case. You can always expose the GFR data through other management APIs. That's possible. Now, you can also record your own custom events. So if you feel that, okay, what's available within the current events about the JVM is not enough for me, I would like to capture my own events. Now, for this one, you need to do a few steps. You also have a custom event in the repo, by the way. You can make your own settings for that event by extending the JDK GFR settings control. You can create, of course, your own custom event by extending the GFR event. And you can register those custom settings in your own custom event, the other settings definition. How do you do that, for example, for a Spring Boot app? Simple. You just register your filter. You can capture those custom GFR events in a dedicated filter. That's what I did. And of course, you can listen for those custom GFR events and record their duration in a listener. So that's what is in my code. And that's how I can capture the information there. So, those being said, let me see, can I get you? Because my application, I hopefully is still running. Huh, it's not running? It died. Damn. Ah. Yes, is the Docker socket still? I managed also to kill my Docker socket. Okay. I wanted to show you Grafana, but hopefully I can restart my Docker socket in time. Just bear with me for a moment. What would be this presentation without a little excitement? So hopefully the rancher is going to start pretty soon. Yes. So I can use the Docker again. I kind of felt it when the writing of the file was there. Okay, just one sec. Yes, it's starting. So what I want to show to you is how I correlated the data that I'm exporting from GFR within Grafana, because I had that Prometheus as a data source in Grafana in my Docker Compose, and that's something that I want to show to you. Hopefully this is... No, don't. Not. Come on. Because it's doing nothing, so it should be like easily starting it. Right now. Come on. Whenever I see the load, it means it's not ready. Note to self, do not try to kill an application in a live demo. But I had to show you that it dies at some point, so. Okay, so it started. Now, this is not going to do a lot of load, so I'm trying to keep it minimal. Okay. Okay. I'm going to let that thing run in the background just in case. So start and probably receive at some point some information. Okay, so it's doing some selects, hopefully. And yeah. Okay. So now that my app is up and running, I can connect to Grafana that I had connected all the way on my local, don't save. And I can look into my custom dashboard. It's shared also in the repo. That's loaded. And I can see how the request runtimes went, of course. And I have also the JC heap summary used within that is being exported from the GFR. Same for CPU load machine total that exported from GFR and captured in Grafana, thanks to the exports that I did from my events. That's what I wanted to show to you. And now that this is done, I want to tell you a few things left. So you can find all the code for this, and you can try to also kill your own Docker socket at home if you want to with the application. Just have to give it like 15 minutes to die. But if you want to try all the code, if you want to try the scripts, and also if you want to play a little more with this, you're welcomed. This is where you can find all. It runs with JDK 21. And throughout time, it was updated from JDK 19 to 21. So if you want to run it with previous JDKs as well, it works. If you are looking for more information on how to use the tools, besides the video where I have the funny hat, there are some other places where you can find information that's useful. And I'm going to share the presentation and the slides so that you can find all the links. Because there are a lot of great information available in articles, but also in YouTube videos done by my colleague Billy Corando, who's specializing a lot in GFR and how GFR is working, so that you would know more on how to troubleshoot your problems. Moreover, in case you're having native memory leaks, which was not my case, but it can happen, there's an article from my colleague Poonam Parhar where you can see how she can troubleshoot the native memory leaks in there. And of course, the documentation, in case it's hard for you to reach it, it's always there listed. And some other examples that other people tried. For example, I think Gunnar has tried using JDK flight recorder events with Quarkus. So in case you're a Quarkus fan, you can try that too. I used the Spring Boot for this one, but you can do more. And if you haven't used JLink so far, there's a nice article on it on dev.java. That was it from my side, and I'm welcoming your questions now on these tools and others. Thank you. Yes, there's a question there.
Yeah, when you use JLink, is the only benefit size of the image, or is there also a performance benefit?
So the question was, when I use JLink, is a benefit only the size of the image or the performance balance? Well, it's not just the size of the image, it's just only what you need at runtime to run your application. It's only that. So I would say that performance part also comes with the fact that the memory footprint overall is minimized from the start, since I'm not adding a lot of unused modules in that. Any other questions? We can also talk after this one if you want to. Okay. Thank you in that case.